Hello, I'm Chuck Martin, and welcome to the Voices of the Internet of Things. With me today is Santh Sathya, founder and CEO of LuftCar. Santh has been hydrogen fuel cell manager at Ford, engineering operation leader at GE Power, global marketing strategy and analyst manager at Siemens, vice president, chief strategy officer at Johnson Controls, and head of product strategy and engineering operations at Boeing. At LuftCar, Santh is focused on creating the practical flying car of the future. Welcome here, Santh. What a background you have.
Thank you so much, Chuck. Much appreciated it. Thanks for the opportunity. Looking forward to be talking to you today.
So tell me what LuftCar is all about.
So LuftCar, at the base, it's a hydrogen-powered eVTOL vehicle, just electric vertical takeoff and landing vehicle. But it's more than a traditional eVTOL, if there's anything traditional about eVTOL. So it's more of a unique airframe that is capable of carrying cargo, and that cargo could be a live cargo or it could be just containers. When I say live cargo, these would be trucks, these would be buses, cars, this would be ambulances that you can airlift. So our airframe behaves more like a flying forklift. So what we're basically doing is building a drone that's capable of carrying road cars so the road cars can go from point B to point C to do the door-to-door delivery services.
So would this be
And that's
piloted
possible
or be automatic?
Yes, it will be autonomous.
So is this going to be piloted or is it automatic?
So the vehicle is going to be autonomous, and we are putting together a cutting-edge AI autonomous package, and that would include depth perception, distance perception, collision avoidance, and sensing of vehicles around, and knowing emergency landing positions. And we are putting together a solid AI architecture for autonomous piloting.
So in many ways, this is the future version of a flying car. It's a flying thing that picks up a vehicle or a car or a truck, whatever. Does that vehicle have to be a custom vehicle, or can it be any vehicle?
It could be any vehicle, but with some amount of customization on the subframe, because the vehicle will have a cage-like design around the subframe so it can be lifted from the top and the bottom. So we lift the vehicle with the 5-point hold mechanism. So it's a top hold and a bottom hold, very much like how a pitcher carries a baseball or how the eagle carries a prey. The subframe customization is something that we have developed, and that's part of our patent. And the vehicle will be carried from point A to point B. And any vehicle can be customized, very much like how you add a trailer to a package to an existing car or a truck. So that's how this customization will be done.
How did you come up with this approach?
So the real inspiration had been many years ago when I saw the James Bond movie Man with the Golden Gun. I was really awestruck with that idea of mounting air wings to a car. But then what they really did in the movie was they actually took an airplane that made it look like a car. But in our case, I've been thinking about this concept on how to really make a car fly. And there have been many companies that have been trying to airlift cars, and they have been lifting cars from the top. So when you do that, it becomes a logistics nightmare because you got to take that air wings to some other place, land it, and it kind of adds more complexity to the airframe design. Baseball is an inspiration. So I looked at the baseball hold. I looked at how eagles carry the prey. So they have a very natural way of airlifting things that move. And that's the kind of design that we are simulating in this. So it's an inspiration from nature. It's an inspiration from sports.
So you must be watching everything else in the industry that's going on, and you see these flying cars, the cars that basically the car then wings pop out of the side of the vehicle. What do you think of that approach versus your approach? Because they're different.
Yeah. So the retracting wings design is something that many people have tried as well. And we could easily do that too, but we are trying to stay away from that model because we believe in energy efficiency. We believe in traveling efficiency, logistical convenience. So taking the wings with you on a road environment is like putting more additional load on the powertrain. And you're burning more energy. On one hand, you're trying to use battery and minimize energy consumption. On the other hand, you're trying to take more payload as you drive on the streets. So we have lots of regional airports. We can easily attach wings to these cars and then detach and drive off and let somebody else come and rent the wings and go. So we are building an interchangeable air module, road module, which will enable customers to keep renting the wings as they go by. So that'll be a new way to think about transportation. So I think this would definitely work, and logistically and energy-wise more efficient than the retracting wings design.
So is this more about transporting a vehicle versus converting a vehicle to be flying?
This would be more about it could be both. It could be about transporting road vehicles in the military case. You can transport tactical small logistics vehicles across contested zones from one point to another, and safe land them in bases, or take air ambulances to the front lines. I could take doctors to the front lines, but it could also be taking people and cargo from one place to another, and then delivering cargo from that place to more of a door-to-door delivery. So it could be both.
Where would these operate from? Would they have to operate from airports?
Not necessarily. We are targeting airports because airports give you the infrastructure space to put hydrogen refueling in. That's the only reason why we want to have them land and take off in airports. But these vehicles also serve people for door-to-door delivery. So we want them to land in reasonably flat surfaces so that there is still an alignment between the air module and the road module. It could be in a cul-de-sac. It could be in a designated parking structures where we could build small helipads where these vehicles can land and they can serve the community. So they can land anywhere, but most likely refueling will happen in designated locations, which would include regional airports.
So what do you see as the initial uses of these, and what do you see as the biggest uses ultimately? Any idea yet?
Yeah, so our primary use would be the two places. One is in cargo, which would be a company like UPS or FedEx or Amazon can buy a fleet of our vehicles, and they can cover a 300 miles radius for cargo delivery. They don't need as many warehouses as they do currently now, and they can serve remote locations because they can fly their road cargo vehicle from the warehouse to a destination 150, 200 miles away, and the road vehicle can detach and deliver. We calculate the cost. It comes 1/10 of the current overnight delivery for UPS or FedEx. And then the second use case would be in healthcare. We do have a letter of interest from Advent Health for air ambulances. So we can take air ambulances to serve immediate care, urgent care, and also there are patients that do not need urgent care because the cost of operations for these vehicles is a lot less. So people that are in secondary care can also still use these vehicles to come to the hospital, so the doctors can go to them. We see plenty of use in military, particularly flying these vehicles from ship to shore and shore to outpost. So typically you will carry road vehicles to some base, and then from the base you drive out the road vehicles. And here in this case, this will be just one wing system that can move road vehicles from ship to a base, and from the base you can drive the road vehicles to outpost. So lots of logistics applications in Air Force and Navy, and we are talking to Air Force and Navy at this point in time.
So why hydrogen?
Yes, and the key differential here is hydrogen, because hydrogen gives you the ability to carry heavy payload through longer distances. Hydrogen fuel cells typically have 4 times the energy density at the systems level compared to batteries. And because of hydrogen, you can achieve 300 miles range. That's the baseline range we are targeting, and you can go up to 500 miles as well. And then you keep refueling with hydrogen. The goal is to have hydrogen infrastructure along the way, and that hydrogen ecosystem is developing even as we speak. And vehicles like us provide a good offtake for those hydrogen infrastructure projects that are coming up across the globe. So hydrogen gives you the capability. Hydrogen typically is the cost of hydrogen keeps going down, and also hydrogen is more of a net zero emissions in total from wells to wheels compared to even batteries. I think every eVTOL company that be serious about regional transportation will eventually have to look for the hydrogen option, unless some miraculous battery chemistry shows up that competes truly with hydrogen energy densities.
So what do you see as the time frame for this, for the development and the launch and so forth?
Yeah, so we are right now building our prototype in Florida, and there'll be another prototype that we'll be building in California. And between those two prototypes, we have committed to FAA that we would send them for certification and validation. And we plan to have these vehicles serving the market from 2027 onwards. Our hopes is that we will have fully functional prototypes available for FAA certification from 2025 late or 2026. And FAA will take their time to certify. There are other global markets that we are looking at as well. Different certification regulations across the globe. In some markets, we can get certification sooner. But one of my personal goals is to have this vehicle serve our country first, serve the military, and then serve our markets, and then expand further. So 2026, 27 timeframe is what we're targeting.
So how do you decide what to do? Because you can do so much with this. Like you can move medical vehicles, you can move trucks, you can move military, you can move people, you can move cargo. How do you decide to focus?
So from my vast experience working in different large corporations, I want to listen to the market, right? So I sensed the market 2 years ago when I started the company, and we set off in a direction. Our vehicle has opened up, like you correctly said, many different use cases. But as we start building the prototype, it's going to create even more awareness and more use cases, and possibly some limitations due to hydrogen. But I think hydrogen is actually opening up more opportunities than we originally thought. It's opening up a big global opportunity for us. So we are going to listen to the market, and defense is one sure market. Air ambulance, cargo, or other markets. We already have a purchase order for 15 vehicles for air cargo. So we will be listening to the market, and we will be letting the customers help us build these vehicles in the right numbers. And that's how we plan to scale up.
So do you initially plan to be moving things versus people, you expect?
That's right. So we are initially planning for the cargo market, and as our certification matures, as the state of autonomy matures, and as the ability to override autonomy and ensure passenger safety and landing emergency conditions, and that system is validated well, we will start putting people on it, and we will approach the regional transportation market. But our initial market should be cargo.
So if you're moving cargo in a vehicle, would the idea be that you move cargo from one place to another, then someone gets in the vehicle and drives it out of the flying forklift?
The road vehicle will also be autonomous to the extent that it can be autonomous, right? So it could be,
Oh,
yeah. So the whole docking mechanism is going to be autonomous. And when the vehicle lands, the road vehicle can detach and go to the destinations. I drive a Tesla. It's a level 3 autonomy right now. So right now, if I have to have a LuftCar, it'll be having a level 3 autonomy. But hopefully, in 2-3 years from now, we'll probably have level 4 autonomy. There will always be a human for the next 10 years in it to override autonomy to whatever extent, but it'll be a combination of human machine interactions.
so would that likely be a teleoperator?
Yes, it could also have a remote flight operator. For defense applications, we could have a remote flight operator. But for cargo, it could be manned, or it cannot be. Doesn't have to be manned depending on the state of autonomy. That's what I mean by we'll listen to the market and the technologies that's available. We are not trying to develop our own autonomy from scratch. We are partnering with companies that do autonomous solutions, and we're integrating them into our vehicle. Elbit Corporation is a big partner for us, who's already in the autonomous space in defense.
So where do you fit in the ecosystem of all these flying vehicles? Because as you know, the market's exploding with these things right now.
Yeah, so the market is exploding right now. In terms of I would say rather the manufacturers proliferated out there, very similar to the 1950s in the automotive industry, and a lot of car makers putting motors on the buggies. But then they all get assimilated at one point, and again, the market dictates who survives, who does not. It's not always based on how much money you raise. It's always based on how you resonate with the market and how your specific technology really fits the market needs or creates disruption in the market. So we believe that we have a very strong, unique technology, and we are a unicorn. We will continue to be a unicorn for some time, and we hope we will have our own narrative, and we are not psyched by all the big players that have raised lots of money right now at this point in time.
A lot of small players too.
Small players too.
So where do you go from here? Like what are your next stages? The prototypes being built and then tested with getting FAA certification?
Yes, that would be our first prototype. Would be a 6-footer vehicle, a demo vehicle that we are building right now, which we plan to take to the Singapore Air Show. Or if that doesn't happen, we'll probably take it to the next available air show, Farnborough maybe. But it will definitely be out there for display, for demonstration of the docking mechanism. The second prototype would be a 2-seater vehicle that we are developing, which is going to be out there, which will be given to FAA for certification. So those would be the 2 critical milestones that we are working on. We are also participating in some very good government grant programs on the hydrogen infrastructure. But as we build the vehicles, we are also building the refueling infrastructure, because the holy grail in this whole thing is hydrogen storage on board. Everybody's talking about hydrogen fuel cells and batteries. They've all been done before, but what's not been done before is taking cryogenic hydrogen on board, which gives you the right range. And that's where we are working with some DOE labs in cracking that problem. And we already have a couple of solutions in hand, but we're trying to make it more efficient. And that's where we're using our grant money on.
So is the primary advantage of hydrogen basically length of flying time?
Length of flying time, refueling time. As you may know, some of these companies that are already flying with batteries, they do take a long time to charge. They have to land quite frequently to charge, and the ranges are limited. And that's going to be a logistical nightmare. It's going to be a high cost operations. I just saw that one company, one of our competitors, one of the more established competitors, signed an agreement for $400 million for 100 vehicles in UAE, right? So that comes to $500 million for 100 vehicles. That comes to $5 million for one vehicle. Right? I don't want my vehicle to cost $5 million. I want my vehicles to be affordable. And hydrogen makes it affordable because you can have the long range, and the cost per mile will be low with hydrogen compared to batteries right now. And we just want to make it very operationally efficient so that it can reach larger population. We want to democratize our travel and reach larger population, and not going to make it exclusively serving a small community. So that's where we are.
So would you ultimately make your hydrogen capability, is that going to be a product for other companies as well?
Yes, I'm glad you asked that question. I keep forgetting to mention that the hydrogen engine that we are developing, just like how Tesla has its own battery system, and how Ford makes its own Mustang engine, we are making our own hydrogen fuel cell engine. We call it Hydrop, and Hydrop is being developed in partnership with Bosch Aviation and with a few other fuel cell companies. And that Hydrop is something that we're developing exclusively for LuftCar, but it can also be custom built for other eVTOL companies. So we will definitely sell them to other eVTOL companies as well. So that's another revenue stream, and we will hit the market with revenue for that by end of 2024 for sure.
So do other companies know that you have this coming?
Yes, we had publicized that like 6-7 months ago.
So how do they find you? They say, hey, we have a flying car already, but we want to change the engine.
They got to reach out to us. Our headquarters is in Florida. Is in Orlando, but we are now moving towards South Florida. My phone number here is 408-905-0036. My email is santh.sathya@luftcar.com, info@luftcar.com, invest@luftcar.com. There are multiple ways to reach to us. Our website is luftcar.com. So please reach out to us.
You may get a lot of calls from that. So what excites you about this?
It's the whole endeavor that we have launched onto, and the kind of receptions that we are getting, right? So they are, some people are really attracted towards the hydrogen, the vehicle concept, the docking mechanism is just something that excites a certain type of people. And certain type of people are, the vehicle mechanism is too complex, but then we really like your hydrogen engine. Like you just said, we want this hydrogen engine to be fitted even in trucks, not only in eVTOLs. That excites some. And some other people are completely enamored with the hydrogen part of it. There's a huge hydrogen fan club out there. People see the potential of hydrogen. And we are playing in all those areas. We are playing in the air and road intersection. And what we do touches different industries, different people, the different lives. So, and different governments. The governments has different priorities, and government, state and federal governments. So we are creating excitement all over. And we are now delivering to our promises. We are building our prototypes. We are building our hydrogen infrastructure projects, and it's that whole delivering to our fan base is what excites me.
Well, I look forward to watching your development and the long range future, and seeing your new prototypes. Thank you, Santh, and thank you all for listening to the Voices of the Internet of Things.
Thank you so much, Chuck.